Good day, everyone. This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on notification button to have more of my video. Today, we are taking a course, a topic in mathematics, and this topic is under vector. And then the subtopic under vector we are taking is the difference between what is called free vector and position vector. Consider this Cartesian coordinate system in 2D form. This is the x-axis and this is the y-axis. Now, look at point A and point B. To be able to locate point A, we move along this arrow from the origin to get to A. Now, after we have gotten to A, to get to B, from A, we move along this arrow to get to B. Now, in normal definition of vector, the starting point here is called the initial point. And this particular point here is the final point. This starting point, called initial point, is known as the tail of your vector. And this final point is known as the head of your vector. And the length of this arrow is called the magnitude of the vector. Magnitude simply means the size, how big or how small your vector is. So take note of that. Now, what do I mean by free vector and position vector? Like this vector A, to be able to locate vector A, I will point A, I will use vector OA. So vector OA will locate the position of point A. Because the tail of the vector OA is tied to the origin, this vector OA is known as position vector. Now, if you look at the vector AB, the tail of this vector AB is not tied to the origin. So vector AB is called free vector. While vector OA is called position vector. Now, let's do an exercise concerning free vector and position vector. Let me say we have a point A, and the vector for point A is given as 2i minus 5j. And then for vector B, the position is I minus 3j. Now, if you have this point A, if this vector A from the fixed point can be written this way, that is OA. So we have 2i minus 5j. Then this particular vector from point O can be written as I minus 3j. Now, we want to determine the position vector with respect to points A and B. So the position vector of this particular position, we are determining the free vector. Find free vector AB, case 1, and BA. Where we have, what we have on this diagram, we have this position vector OA and position vector OB. So because the tail of this vector is not tied to the origin, this is the free vector. So we want to determine two of these free vector. Now, to get A to B, free vector AB, that's question 1. That means we move from A to B. Instead of moving from A to B, we can move here and like this, and we are moving against the arrow, so this vector will be negative. And because I'm moving towards the arrow here, this vector will be positive. So vector AB will be vector B minus vector A. And vector B in column form, I take the coefficients. So the coefficient will be 1 and minus 3. Then minus for vector A, I take the coefficient to be 2 and then minus 5. So I combine these two now. 1 take away 2 will give us minus 1. Minus 3 minus minus 5. Minus times minus, that's plus. Minus 3 plus 5 will give us plus 2. So that means vector AB, the position vector AB is minus 1 and 2. Then the second one says we should find the position vector BA. That means we need to move from B to A. That is from this B back to this A. So to move from B to A, we move against the arrow for OB and then the same arrow with A. So that means the vector B will be negative while the vector A will be positive. The reason is this: I'm moving from B to A. It's like moving against this direction and moving along this direction. So it's going to be A minus vector B. And then taking the coefficient of this vector A, 2 minus 5. Minus 5. Then taking the coefficient of vector B, that is 1 and minus 3. 1 and minus 3. So combining these two now, 2 take away 1 will give us 1. Minus times minus is plus. Minus 5 plus 3 will give us a minus 2. So the position vector BA is 1 and minus 2. Then I want us to take note of something. What is the resultant of combining vector AB and vector BA? What will it give us? Now, the result of vector AB that we got the other time is minus 1, 2. I put it minus 1, 2. I want to combine with the result of vector BA, which is what we have here, 1 and minus 2. I put it 1 minus 2 there. If you look at it, minus 1 plus 1 will give us 0. 2 minus 2 give us 0. So what I have here is called a zero vector. A zero vector is a vector that has zero magnitude. A zero vector is a vector that has zero magnitude. No definite sense. No definite sense and direction. This brings to my mind, what is magnitude, sense, and direction of a vector? Look at this vector that I have here, vector R. If the vector make an angle theta with the horizontal x-axis, the magnitude of this vector, OA, is the size of this line. This is the magnitude. And the sense is the direction of movement along this line. The sense is this, along this line. So a zero vector has no magnitude, has no definite sense and direction. The direction is the angle, is the measure of the angle that the vector makes with the horizontal x-axis. Thank you so much for listening to this particular topic. The topic on evaluation of an exercise under position vector. And I also use that to also explain what a zero vector is all about. Thank you for having my time. Have a nice day. Bye.